So before we jump into this video, this is kind of a part two to another video I made, but you don't have to watch that video. That video was the one I did on how to merge different scans I did of a very small plastic gear. And then this one is just me kind of messing around. I pulled my mesh into my CAD software and just did a quick reverse engineer. Nothing fancy, nothing all that hard, just wanted to give a quick demonstration of my process to anybody that might need it. If you are having trouble merging scans, feel free to check out that other video. But if you just want to see a quick reference of the general process I do for reverse engineering from scratch, here you go. This is what I do. It's not the best practice out there. There's other ways people do it, but this is my flow. Hopefully you find it helpful and enjoy. All right, so I've got the gear model imported into Onshape. Onshape is an online CAD software. It's the one I prefer to use, mostly because of the fact I can use it across multiple devices without installing any extra software, and it's got a pretty great free tier. Works great for my needs, and it just so happens it works a bit better than Fusion does for me when it comes to high-ish polygon meshes. This one is about 150,000 polygons, but yeah, it's pretty straightforward. If you haven't used CAD before, to be honest, if you can do basic math and use MS Paint, chances are you can get started in CAD pretty easily. Now, I'm going to reverse engineer this gear, but the first thing I need to do is actually align it. So you can see I've got top, front, and right planes in this document, and I want to center it and align it with the smaller gear on the top. Orientation is really up to you, but I 3D print, so I tend to orient my models for 3D printing when I start out. But yeah, first thing I'm going to do, and this is my workflow. There may be simpler ones other people use. This is what I do. I don't use quick surface or anything, simply because cost. I'm a hobbyist. But yeah, first thing I do is I come and I create a plane. You got different ways you can do it. I always use 3-point, and what that's going to let me do is grab 3 points from this mesh and actually use those to create a plane on. So I've used 3 that are on that bottom side right there. Those should be relatively straight. And there's always a possibility that, it's not going to be perfectly aligned, but if it's 99% of the way there, I can still work around that. But now I've got that new plane created. That's going to be plane 1. And when you have these planes, you can customize their dimensions because they don't interact with the model in any way. They're really just a point of reference in 3D. And I'm actually going to hide that plane. And actually, I'm going to hide all my planes using the P hotkey, just because I know they're there now. I don't really need them at the moment. But what I'm going to do now is start a sketch. So if you haven't done CAD before, you always start by drawing. And for my sketch plane, I'm actually going to use that plane 1 I just created. And now I'm going to hit U on my keyboard, which is going to enable use or project. So what that does is let me either use features from other models or project them onto this plane. Now, since this plane is now perpendicular to this shaft, I can actually select points on it. They don't have to intersect perfectly. But if I grab a few points, you'll see how it projects down to that sketch plane I created. And I can come along and grab 3 of these. And if it was a rectangular surface, you can still work with 3. But I try to find something that's roughly centered on my model. And depending if it's circle or rectangle, I'll select my points accordingly. But since this is a circle, I'm going to select the 3-point circle tool. And this is going to let me use those 3 points I grabbed from the actual mesh to create a circle in my drawing. You can see I'll hit N to reorient. That's going to normalize it, but It's about 10 millimeters, almost 10 millimeters on the dot. And the slight deviation on that is likely just due to the fact that this has a slight taper on it. So if I didn't select perfectly at the same height, that can happen. Honestly, I would have been better off probably selecting from the circle here or the edges here, but hey, I'm going to work with what I already selected. But that's all I'm going to do for that sketch. So that's just creating a reference that I can use in relation to the rest of the world here. Now I'm going to use transform. The entity I'm going to transform is actually going to be the model I imported. I'm going to transform by make connectors. Now, make connectors are typically used for assemblies and when you're putting parts together. If you're not familiar with CAD, don't worry about that. But I can use my from make connector and select the center of that circle I drew. And my to make connector, I'm going to select in this document, I've got an origin point. So I'm going to select that. Now if I select front, you can see it is upside down. I'm just going to use this arrow tool to flip my primary axis on that. And there we go. I've now got my model perfectly oriented in relation to those planes. I'm going to hide this plane again and that drawing because we no longer need it. But you can see if I zoom out here, I've got a perfectly centered and aligned model. Now, one thing I do want to do while I'm in here is before I go any farther, because I've got these axial arms on it, and this will help me out a bit later on when I'm working with the gear teeth, I'm going to rotate this using the same basic process. So I'm going to select rotate. The entity, of course, same thing. And this time for my axis, I'm going to use the origin point. But what I'm going to do now is switch this to my bottom view and rotate this a small amount and see where I need to go to get this properly aligned. So that looks to be pretty close at 10 degrees. 9 looks a bit better on this tooth, but I don't think that tooth is perfectly centered. Although looking here and here, I can see the teeth on this outer gear do align better for that. If I look at that smaller gear up top, you've got an odd number of teeth, so you don't align properly. Was that 15 tooth gear? Yeah. So we'll just go ahead and use that as our alignment. So there's a couple different ways you can do something like this. You could draw the gear teeth manually, but luckily gears are pretty standard. I'm not an expert on them by any means. I'm very much hobbyist. I'm not an engineer, but I do have this add-on tool installed that I like to use in my designs that lets me generate gears. So I can just grab that origin point again. You can see I've got that there. And how many teeth does this have? 1, 2, 3, 4, 5, 6, 7, 8. That's about that. That's 52 gear or 52 teeth, I believe. If I'm off, I can come back and do it. And I think the diameter of this model is about 30 mil. 32. 31. 31 looks pretty close. Now, this did generate. My tooth count looks correct, but it did generate just slightly off. So what I might do here is come back to this transform I did beforehand. Instead of centering those teeth, I'm going to go ahead and rotate it a little bit more because looking at it, this top arm here seems to line up right between those teeth. So I think it's going to be about, what, 70-ish degrees? $69, that works for me. So we can see here we're roughly splitting. Maybe I do want to go full 70 on that, or 68. Just looking at how the teeth align on my axes here. Yeah, I think 68 is going to be our final alignment. Yeah, so you can see now how the gear I generated is lining up with the teeth from that model. And I didn't mess with all the settings on this, but so far we're looking pretty good. My model did get a little, I call it blurry between the teeth, and that's just because I didn't spray this gear or anything. It's got very fine teeth. It's that white plastic that's kind of translucent, and it creates, I don't know how to explain it. In the world of 3D rendering, subsurface scattering, light that hits it doesn't bounce off right away. It kind of diffuses on the surface and beneath the surface before reflecting back to your eyes. And that can cause a bit of muddled details. And if I'd sprayed it, it wouldn't have been super sharp, but that's on me. But sometimes when you're doing reverse engineering, a good enough model is good enough. Yeah, so I'm happy with that. And the next thing I'm going to go for is going to be, well, before we do that, let's go ahead and bring this, call it axle, I guess, up. So I'm going to create a sketch. I'm going to hide the reference scan. Oops, small line at the top. And let's bring that back now. I want to try and bring this to roughly match that diameter of that star of that neck. Now it's got a bit of a chamfer there, or fillet, excuse me, which could either just be from the scan or from just injection molding tolerances. But I can see it's about 10.5. I'm probably going to bring that down to 10, because then after I get this feature, and you can see later, I'll go ahead and bring it in a bit or fillet it down. But it looks like we got a bit of a taper here too, don't we? You know what, let's go back into that. Cool thing about this is hide the surface. You can always come in and change a measurement. So I'm gonna got 10.5 on that. Yeah, it looks good. And what I'm gonna do now, hiding the wrong piece here, I'm gonna grab that, I'm gonna extrude it out. And what I'm gonna do for this first extrusion is I'm gonna bring that to the same height that we've got here. So that's gonna be, if I had to eyeball that, about 5 or 6 mil, maybe 5.5, 4.5. And then I'm going to go ahead and match the next part to this, and then I'll be able to use the fillet tool or the chamfer tool to blend that in. But you can see it looks like we may have a little bit of a taper on that. It's not much. Yeah, we do have a taper there. It could also be deformation in the original plastic gear I scanned, just from being under load for so long. It's plastic. Plastic warps. Plastic deforms over time. But let's see, we could do a draft on that, but I don't think we need to. A draft is when it just kind of tapers coming in. Now, I don't think we need a draft. We'll just keep that as is. Can always change that later. Now, next thing we're going to do is hide the surface again. That looks like it's probably going to be about 8 or 9 mil right there. But let's go ahead, hide that. Do another sketch. And this is why I said before, if you can use MS Paint, you can do this. I have a feeling that's going to be 8 mil. Oop, hiding the wrong thing. Let's go and view that again. So to my eyes, it's kind of hard to tell from this angle. Let's go ahead. I think it's 8.5, to be honest. But what we can do is hide that. Hit extrude, bring this back to where we can see it. Something you can do quite easily is when you're extruding, you can do a preset distance, or you can say like up to a specific feature or point. So you can see I clicked that vertex, so it brought the height there. But just because I want to be as exact as possible, you know, when this was originally designed, they used exact lengths, probably metric. Let's merge that back with our gear. So looks to be what, about 12.5, oop, 14, 14.5. 14 1/4. Surely they didn't do this in Imperial. Maybe I should do that up to vertex, huh? Yeah. I don't know what they did, so I'm going to go ahead and trust the scan data. Because that seems the most accurate to me. All right, so we can see here, you can kind of see where the mesh from the scan intersects with the CAD model. We didn't get that on this. There's two different ways you can fix that. You can either well, let's go ahead and make that invisible again. You can go and move face and select the degree you want to increase it by. Since this is a circle, if I were to do 0.25, it's in all directions, it's going to increase it by 0.5 mil. I can see right there, that looks pretty close. So I'm probably off by 1 millimeter. I could keep it like that. Or what I prefer to do is keep it matching in my sketch that I did. So I'm going to come in here, double click that measurement. I'll change it to 9 mil. When I save that, oh, too much. Eight and a half. That was looking right. A little bit of trial and error here. Are you 8 1/4? I swear, did they do this in Imperial? .815. All right, that's what I'm going to go with. This gear really might be designed in Imperial units. So last I'm going to do, on this side at least, is another spur gear. I'm going to select this as my connector. Oh, it hit origin. Delete that. I'm going to hide my surface for a second. And what I'm going to do is select the make connector of this circle surface. It's on top. We don't want that. We want to intersect. So just change the primary axis direction on that. Bring my surface back in, and that is a 15 tooth gear. And I would say the diameter on that, if I had to eyeball it, I could have drawn a circle to measure that. Would have been a good idea, but bring it down 12 and a half. Spot on 12. Spot on 12. All right. That looks good to me. Now, this gear does have a chamfer on the bottom. There's a couple different ways you could approach this. I'm not sure which one I want to take yet. What I'm going to do is change its height to match before the chamfer begins on this gear. So I'm probably going to add another couple mil onto that. 6.5. 6.5. Then I'll come in and chamfer it later. It's not strictly needed, but I'm trying to keep this as accurate to the original as I can. Now, this will happen sometimes. You can see our teeth aren't perfectly aligned. Depending on how things are built and whatever you're trying to replace, you may need to, you may not. So if this was, say, being used to adjust torque or change the input to output from a motor, and say the motor had a spur gear that was running against this one, and this is just the output gear, this doesn't have to be perfectly in line. But sometimes you have equipment that the gears are timed to one another. And if that's the case, you do want this to match. So that's just a simple transform. We're going to rotate it just like we did our mesh before. Nope, forgot to tell I'm going to use this as a mesh connector. You can also, if you just select axis, use like a drawing. So I could use that. Wow. 30 degrees is looking pretty good. So yeah, that 30-degree rotation got us exactly where we needed. Very happy with that. All right. What I'm going to do now is called a Boolean operation. A Boolean is simply either joining two surfaces or two objects. So if I were to select that gear and the original, you can see they become one object. I'm going to flip those just because I want to keep the original as a parent. Or you can do subtract, right? A subtract would say I selected my target or my tool as the big one I did, and my target as the one I just created. Let's hide my surface here. You'll see that ceases to exist unless I say keep tools, but it subtracts it from the gear I just created. I don't want to do that. We're going to be joining these. I'm not going to use keep tools because I don't want to keep extra meshes around. So you can see now this is just one object, and I did that so I could come in and see if I can chamfer that. It might not work because of these curves, but we will find out pretty quickly. Just grab an arbitrary number and shrink down from there. And this angle's off on that, but let's go ahead and make my surfaces visible. There's a few different ways you can do a chamfer. This one doesn't need to be equal distance. We're going to either want to do two distances or distance and angle here. So distance is going to be how far out it comes from its original point. So if we were to do, say, 2.25, that's going to bring us right onto that. Slightly off, but that's fine. And our angle is probably going to be, actually, let's bring this down. It looks like it's going to be about 60 degrees. So we can likely drop our distance now. Yeah, that looks close enough. And what I can also do, oh no, I wouldn't need to. I was gonna say I could grab this face and adjust its position ever so finally if I need to, but I'm looking at each one of these and you can see the scan data is intersecting with it pretty well. More so on one side than the other. That's just telling me that I either didn't align perfectly when I imported, or there was some deformation on the gear when I scanned it. But that just happens, you know? Parts warp and deform over time. So we've got a nice chamfer there. I will come back and do this bore, but that's going to be at the end after we match the bottom here. So I'm going to come in and hide these reference sketches that the gear tool creates. I don't want to see them. But now I'm going to go ahead and create another drawing on the bottom of the larger gear. And I'm just going to draw another center point circle. So that's probably, actually it probably is 10.25. That does look like it's got a draft on it. Could be my eyes playing tricks on me, but we'll find out. Let's see. I'm sorry it keeps doing that. It's used to, whenever I go back to my reference planes, it likes to go crazy with the zoom. Yeah, I didn't do a good job bringing this in, or the model did warp a little bit. But that should be fine. I don't know if I want to keep that 10.5 or not, though. I kind of feel better with that at 10 than 10.5. Yeah, we'll keep that as is at 10. And that's pretty small. What was that, about 3? 2.5, 3? Yep, and you know what? I'm indecisive. Let's go back 10.25. Yeah, that 10 and a quarter is right. That's it. N to reorient so I don't have to zoom all the way back out. Let's do another sketch. You have to excuse me if I use keyboard shortcuts. It's really weird for me to go up that bar up top. So that's coming at 9.1 roughly. So let's do that 9, see how that looks. Change it again if we have to afterwards. Let's grab that. Extrude it out. I'd ballpark that at 4, 3, 3.25. Yeah, I'm gonna bring it up to 3.5. That doesn't look right to me though. Oh, rookie mistake. Let's see where that clips through it, through the best. 3.35. Weird. I'm just going to do 3.25 and hope for the best on this. Now, last thing we're going to do is on this plane that we just created, another sketch. And this time I'm going to hide my spur gear so I can match that inside diameter. So typically when you're working with any kind of gear, they have a shaft that they're going to go on that's going to be a pretty standard size. I didn't focus on scanning the shaft that much. I probably should have. But looking at this, I think 6 mil is probably right. What I want to do is find some points on this that look like they're on a good vertical plane, like this one part here. And project those like we did in the beginning onto the sketch that we created. And if we hide that, you can see like we got this point I projected right here. Since we know that that's pretty accurate, now when we go do our circle tool, hitting the wrong key here. Let's see what that comes out to. See, 5.95, that's telling me this is going to be 6. So now I'm going to hide my scan. And for this feature right here, I'm going to do an extrude, remove, and I'm going to do up to the face of this gear here. And that's just going to say remove all the way through. So now we have a pretty good reference model. Let's go and realign this here. Missed my CAD mouse. What I mean by that is I lost my CAD mouse. But this is looking pretty solid, but if we compare it to the original model, you can see we've got some features here where they transition from one to the other pretty well. So we're going to do a chamfer. Let's hide that surface again. And that one looked like it was equal distance because it's about 45 degrees. I grabbed that whole face. We do not want to do that. I want to grab just that edge. Oh, you know, maybe it was an equal distance. It does look a little steeper than 45-degree angle. So let's adjust our angle because it's another 60. All right. Let's bring this down. There we go. And let's see, before we save, if we can apply that to the same one here. No, it doesn't like it. Oh, it's got the direction override. We don't want to do that. So that, yeah, that applies well to both. So it saves us a little bit of time on that. And let's hide this for a second. Yeah, we don't do anything to the bottom of that one. So we've got that looking pretty good. I also noticed, I can't recall if this was on the original or not, but some like this I know was rounded. I can't recall if it also rounded this off. So when you round something like that, it's called a fillet. A fillet if you're fancy. I'm funny. But I'm just going to grab my fillet tool here and just select these edges, see how they look in comparison. I remember that had a smooth transition to it as well. Let's view our original. I might be going a little overboard on that. Let's bring this down to, see if they use a static for that, like 0.7 for that. Yeah, see, that brings it down. I think they use the same measurement for their fillet that they did for their chamfer. I almost feel like they did it on bump. I could go get the gear and look at it, but I'm just going to work from my scan data. Should not have done that. I'm just going to undo that altogether. I wanted to see if that fillet also matched on there, but it did not. Start with the faces you know. Actually, maybe it goes there though. Let's see how that looks. Yeah, why not? That's not actually interacting with anything in the actual functional part, to my knowledge. Famous last words, but let's roll with that. And I'm actually going to grab these edges here. It's just, nope, maybe not. All right, those ones are different. That or my measurements are ever so slightly incorrect, but everything can be adjusted. Oh wait, did I do that last one at 1? That'd be why. That's a great thing about CAD. You can always come in and adjust any point. Yeah, see, there we go. Let's compare that to the original scan. Yeah, that looks spot on. Let's grab this one again. Switch to front and zoom back in. You know, if I hit my planes, I don't think that would happen. Yeah, because the planes are being used for reference. So now, let's come back into that fillet and do this one too. We're looking fairly accurate. This would be good to print, but the one more thing I want to do is add those bars that we have here, just because I want to be as close to the original as possible. Now, one thing I did incorrectly is I probably should have done that before I did my fillet and probably my chamfer too. You want to save that kind of stuff for the end. But I can back up my history tool here. Hide that again. So what's that? I'll call that 27, oops, 27 and a half. Good enough for government work. And what we're going to do for this one is actually use the diameter from this just to keep things the same. And what that'll do down the road is if we do end up changing the diameter from that drawing, it'll reflect in this down the road and update that part of the sketch. We don't end up with any weird issues with our geometry. Now, let's go ahead and hit N to reorient to normal on this. This isn't perfectly straight, but I'm going to roll with it as it is. So I'm going to draw a line here, but I'm going to hit Q, and we'll keep it perfectly straight in my drawing. But that's going to create what's called a construction line. A construction line, dashed lines like that, they're there for reference. And they can be reference for you, but also reference for other things to be drawn from. So now I can do another line to there. And you can see I didn't give it a measurement. It's blue because it's not constrained. It doesn't have anything that defines exactly where it is. But that's okay for now. I'm going to use mirror, select this line to mirror, and then select that. And you can see we're pretty close dimensionally to the thickness of that arm, bar, whatever you want to call it. But now I can hit D to dimension and say these, I bet that's supposed to be probably 1 3/4, 1.75. I could do 2, but let's roll it like that. And then, so I don't have to repeat that process here, I've got this tool called circular pattern, and I can grab those. And you can see how it's already put them there. You can change how many you get by changing the repeat number. So if I were to do 6, you can see I've got 6 now, right? Coming around. But let's actually hide the surface and make it a little bit more visible. I can do 3. just like that. Now you can see these are blue because before we finish them, they're not constrained. That's because the center point is in the center, but it's not locked there yet. It's silly, but you can grab it, put it back on, and then click out, and they'll be constrained. If I didn't do that part, so let's undo that. Use that same tool again. It's 3, but that's not constrained. So they're not constrained. And it's always good practice. Anything that's critical to either geometry or reference for geometry should be constrained. So if you change anything else through this history line, it reflects on all points after that. But now you can see we've got these 3 surfaces here. I'll make both my gear and my original scan visible. I'm going to do a remove, and I could just do right up to that surface because that one is really flat. Let's hide that gear for a second. You can see it dragged it right down. Now I can bring this back, this history bar, and you can see it reapplied. Oop, hit the wrong thing. Those adjustments I made before. But I do want to change that because this one right here shouldn't be in there anymore because I selected at the wrong point. It should actually be these here. Now you can also select faces and you'll see it'll chamfer all the way around, but I'd like to be more precise with that. You know what? I think those arms might not be that high on the original. Let's see. They are not. All right, I'm going to save that as it is for now, but what I'm going to do is back this up. Let's make that sketch visible again. So I can select those 3 faces. I'm going to remove just a bit of those. It's probably about 0.5 mil. Let's make our reference model visible. See where our clip is. Yeah, see, those actually, maybe it is supposed to be to there. I'm wrong. Disregard all that. But if you did have to go back and change something, it's that easy. So I'm going to reselect this fillet tool, reselect these edges again. And I feel like these should also be rounded off. Oh, but it brings that round into there. So you know what I'm going to do? This is one of those times you're going to want to split your fillet into multiple operations. Oh, am I though? Because if I do that and then I select in a future one, it's going to bring that fillet all the way around and round that off. Is that rounded on the original? It is, isn't it? So that would be okay. And if I was going for 1-to-1 on that, yeah, let's just start with the horizontal ones. I don't want to do those at the moment. I'll probably do what's called a variable fillet or partial. Excuse me, fillet. I'm saying fillet now. Good Lord. Can you tell I've been going for a while and I'm tired? That's what happens when I don't plan stuff out and I just decide to jump into a project without any forethought. Here we go. All right. Let's go and save that. There's our original. Here's our reproduction. All from that scan data. Now, if I were to be 3D printing this, there's certain things you want to keep in mind, right? 3D printing isn't perfectly accurate. So right out of the gate, this right here, 6 mil diameter, it came off a shaft that was 6 mil. In injection molding, you know, they cool in the mold. You don't have to worry about contraction or anything like that. But with a 3D print, it's cooling as it's being manufactured. So either A, you want to make sure you got your printer calibrated to adjust for hole diameter like that based on the material that you're printing with, Or B, you want to design with an offset. Typically, like, you know, anywhere from 0.15 to 0.25 millimeter, depending on your printer, your filament, things like that, to account for inaccuracies in printing, but also the contraction that some materials do when they're cooling. So it could draw a perfect filament path that just ever so slightly shrinks, and then you wouldn't be able to get your shaft in. You could also drill it out after it's printed. But just something to keep in mind. I tend to typically create my models accurate to my scan and either use hole adjust in my slicer, or I'll come in later. If I'm feeling impatient, I'll do a face move and just adjust it by whatever I need to get printable, we'll call it. But yeah, we did a solid reverse engineer on that. And when I'm not rambling into a microphone and trying to explain what I'm doing, you can do something like this simple gear in about 5-10 minutes. It's really not difficult. If you can use Microsoft Paint and you can think in 3D, which I hope you can do if you're doing 3D scanning or 3D printing, you can jump in and start doing stuff like this pretty easily. Now, some things like curved surfaces, organic surfaces, they get really annoying. And I have a pain in the butt workflow I follow for those. I've watched videos on software like Quick Surface where you can just grab reference points. I believe Fusion has a flow similar to that, where it's really easy to create a surface. Onshape kind of can, but it's not as good in that regard. But for the kind of stuff I'm doing, I find it perfect. But yeah, that's my quick reverse engineering of a tiny plastic ear. I really hope you found this useful. Thank you for listening to me ramble on about this kind of thing. If you did find it useful, let me know. If you didn't, thank you for hanging out and enjoying the ride with us. I hope you at least found it entertaining. Get out there, scan and reverse engineer something.